In this video I'm going to take a look at how Azo dyes are produced from aromatic amines. So we'll look at the first step of the process now, and that's known as Diazotization. What that means is we're going to form what's known as a diazonium ion, and a diazonium ion contains this N2 plus ion. So we'll draw that out now. So we'll start with phenylamine. And what we need to do is react that with a couple of acids. The first one, which people always get the name wrong because it looks so much like something else, HNO2, that's nitrous acid, not nitric acid. So we're going to react the phenylamine with nitrous acid, and we're also going to have some hydrochloric acid in there as well. So what that will do is it will form a diazonium ion, and the important thing to remember here is that the positive charge, this positive charge, is actually on this first nitrogen. So there's the diazonium ion. We would also make 2 moles of water. We'd also get a chloride ion from the HCl, and what that would do is it would combine with the diazonium ion and form a diazonium salt. Now most of the reactions that we study have to be carried out with heat as a condition, so it might either be reflux or warming or sort of general heating. This reaction is probably the only one that we study that actually has a low temperature. Now the temperature specified is below 10 degrees Celsius. So the second step is we are going to take the diazonium ion, or diazonium salt as I've drawn here, and we're going to couple that. So all that means is we're going to join it together to a phenol, and it needs to be in the presence of alkaline. So I've got sodium hydroxide here to create the alkaline conditions. So we're going to couple these 2 molecules together. You can see that's happened there. So we've created this rather nice looking molecule here. This is called the Azo dye, and it's because it contains the azo group, which is this part of the molecule here. You can see the other products are sodium chloride and water. So we'll have a look at this slightly more complicated example of an azo dye now, and we'll ask ourselves, how would you make this? So the best thing to do is to sort of chop the molecule in half. I'm going to do that sort of there, and this top part here, well, that will have started out as the aromatic amine, and the bottom part here, well, you see the OH group there, so that's obviously going to come in part 2, and that's going to be the phenol. So which aromatic amine are we going to use to make this part of the molecule? So that's obviously going to start out as 4-methyl nitrobenzene. So if we reacted that with the nitrous acid, HNO2, and the HCl, and we carried that out below 10 degrees C, we would make the diazonium ion that we want. So CH3 there. Remember, it's N, triple N with the plus on the first nitrogen. And we'll turn that into the salt by putting the chloride ion in there, and we'd also make 2 moles of water. The phenol that we would need I've drawn down here, so that's 3-methyl phenol. That is going to then be coupled with the diazonium ion in alkaline conditions and form our azo dye. And hopefully you can work out, there's the equation for that there. So we've got the diazonium salt with sodium hydroxide, there's the phenol that we need. So we're going to couple these 2 compounds together. So there's the azo dye, its azo group there, and we'll get an HCl and H2O as well. We'll just finish with a summary now of the 2 steps. So step 1 is called diazotization. Things to remember: it must be carried out at temperatures below 10 degrees C, and the acid used, HNO2, is called nitrous acid, not nitric acid, and remember there's also HCl present in that step. The whole point of that is to form the diazonium ion, and remember the important thing here is that the positive charge is on the first nitrogen. You can actually get away with writing the formula like this, and the thing about that is you're not committing yourself to saying where the positive charge is, so you can actually get round. If you forget in the exam that it's on the first one, then you could get away with that. That's absolutely fine. If you put that positive charge on the second nitrogen, I'm afraid that would be marked wrong. But I always encourage my students to go for that because it shows clearly the structure of the ion. And step 2 is called coupling. So in the coupling step we react the diazonium ion that we've just made with a phenol, and it must be carried out in alkaline conditions, so I'm using NaOH there, and it produces this azo compound, and it's called an azo compound because of this N-double-N bridge between those two benzene rings. That's the azo group, and so these are typically used as dye molecules, and therefore it's called an azo dye.